All right, so let's continue from where we stopped. That's why I always say let's be taking notes. Don't depend on these videos. The internet is not that stable. So see this as a classroom. You have to be taking note along. All right, so let's uh, continue from where we stopped. From where we stopped. And okay, now that we have the profit function, we have the profit function P of X equals to minus 2.5x raised to the power of 2. That was the original profit function, 47.5 x, then minus 85. So we factorize this using a condition of like P of, after using this condition, we find a solution that x equals to what? 2, or x equals to what? 17. In some texts, you will see x1 and x2. So these are the roots of the equation. And we talked about this is the break-even quantity. We talked about this already. Quantity. So what it means here, profit is equals to 0. And profit equals to 0, it can also equivalently mean what? Total revenue equals to total cost. So we break even. So what it means, if we take this profit function and we substitute 2 there, 2.5, this is point, raised to the power of 2 plus 47.5, then we have 2, this is 5, minus 85. This should give us 0. You can cross-check it. So if we also put P17 here, 2 plus 47.5, then we put 7, this is 17, sorry, this is 17, then 17 raised to the power of, okay, 47, then minus 85 should give us 0. So these 2 points, so if you even go further, you put revenue at this should be equals to the cost at this. These are some of the conditions. So if you take a revenue function and substitute 2 there in place of x, you take cost function in and substitute x with 2, the total that you will have here should be equal to the total that you will have here. So these are some of the conditions. So now that we know this, these are some of the things that you should know from your principle of economics class. So we have x2, x1. We have x1 equals to 2, and another x is equals to 17. So these are the point, the break-even points. So how can we use this to calculate, to answer our question? That is the range at which profit or production becomes profitable. So we go on, let's try to visualize this with a graph. So at the vertical axis, we will have profit function. So at the horizontal axis, we will have the quantity of coffee maker produced. So remember our roots, x1 equals to what? 2, and x2 equals to 17. So what you will do, you locate, these are key, they are very, very important. So you will see that we locate this on our x-axis, or the horizontal axis. So let's say that this is 2, and here is what? 17. So another key important thing is to find, we know that when x is 2, profit is what? 0. When x is 17, profit is what? 0. We computed it here. We have them here. So the next step that you should take is that we want to know. So from here, profit is 0. So it meaning that after 2, so let's assume 3 is here. And let's assume 16 is here. So the profitability will be from where? If we produce 2, the profit will be 0. But once we produce 3, then we will start making profit. And as we goes on, we will start making profit up to what? 16. But once we hit 17 of coffee maker, when the production is 17 coffee makers, the profit will be 0. So beyond here, beyond 17, like let's say from 18, coming up to positive infinity, the profit will be negative. So profitability is between 13 and 16. But we are not only interested in making a profit, we want to also know where the maximum profit lies. So to know the maximum profit, all what you need to do, that is maximum profit, if we want to know it, let's represent it as this, maximum profit. All what we need to do is what? You add, you find the average of what? The roots, that is x1 plus x2 divided by 2. So what we will have here, x1 is what? 2, and x1 is 2, x2 is 17 divided by 2. So our maximum, the quantity that we should produce to have a maximum profit is what? 9.5. We don't have this in the book. So from between 3 to 16, we will make a profit. But the maximum profit lies when we produce what? When we produce 9.5. So if you produce from 3 to 16, we will make a profit. But the maximum profit lies here. So we want to know if we produce 9.5 quantity of coffee maker, what will be the profit now? So we calculate this. So to calculate this is very simple. We will use this profit function to calculate it. So wherever we see X, so to calculate this point, we just use this 9 profit as a function of 9.5 equals to minus 2.5. So we replace the X, which is the coffee maker, by 9.5 raised to the power of 2 plus, I'm trying to make best use of the space, 47.5 or in bracket 9.5, then minus 85. So if you do this, we will have what? 140. So the answer 9.5 will give us what? So if you evaluate everything here, it will give us 140 0.625, or you round it up 63. So here we will bring this 140.625. So all what you need to do, you connect this dot to here, and you connect it to where? To 17. So we will have something like this. Then here we connect it. So you will see that maximum profit happens here. If you produce a tree, you will make a profit, but it will be here. If you produce, let's say 16, you will make a profit, but it will be here. So the maximum profit, this is the point. So then this cuts here, it goes down. So this also will cut here, it goes down. We need to know this intercept. And this is very simple. It is telling you that if x equals to 0, what will be the price? But to even know it very simply, you can just look at the profit function and know where this lies. Always here, it will be this one, the value that is here. So that will be negative. That is the constant term there. So this is what we have. Remember, the question is asking us, you understand, what range or what values of X where the production is profitable. So we know that this is X, that is the quantity of coffee maker produce. So the range at which the production is profitable is what? When X is less than 17, and when X is what? Greater than 2. So it's between what? 3 and 16. So this is our answer for that question, that at what values production is profitable. So mathematically, this is it. But in a simple English, is from 3 to 16. Because it said that X is less than 17, meaning that the highest we can have is 16. The highest integer. So here also, it says that 2 is less than X. In another word, X is greater than 2. So this is, so from production, if we produce from 3 to 16 coffee makers, we will make a profit. But that's not the end of the stories. We want to know where the maximum profit lies. And to do that, we have just did it. You just the roots plus this, and you divide it by 2. So after 9.5, you will make a profit, but the profit will be lower. So this is our answer to our question. The profit, the values at which production is profitable is between 3 and 16. But the question can go forward and ask you, what is what is the quantity that must be produced to produce a maximum profit? It can ask you for this, the question. It can ask you for this, we know how to calculate, and it can ask you. So this is the maximum profit. So this one is what? The maximum quantity that must be produced in order to maximize profit. So this graph is very, very important, and everyone should be able to know how to draw it. So you will see that if you even go beyond 17, like let's say here, 19, the profit that your profit will be negative. That is, you will be making a loss. So if you produce less than 2, like let's say here 1. So this is the graph. You will touch here and the profit will be negative, which means you are making a loss. So if you have questions, you can go on and ask before we start another example. Any question? Any question?
I think this question is crystal clear. The answer is clear.
Okay. So let's go to the next question. One more question. Then from there we will do brief introduction to composite function. Then we will call it a day. Today or maybe today or tomorrow I will send the second assignment to you. I have received assignment, but some of the scannings I can't. They are really they are not clear, and there is a likelihood that I might call some of you to resubmit your assignment. So the next assignment, there is nothing like scanning or sending through the internet. We have to submit it to the campus, hard copies, hard papers. Some of the scannings were not clear at all. So I might even call you to resubmit it. That is if you submit it before the deadline. So let's go on and look at another example. And a student complains that there is not a lot of examples, but I gave you material. I will give you another exercise. We have a lot of examples there. Exercise there that you can do as well. So you also have this. Let's try to, this question, what it's doing is trying to evaluating cost function. So when you have a function, before you go on to answer question related to it, first try to understand the nature, like what kind of equation or function I'm dealing with. Is it quadratic, is it linear, or is it even beyond quadratic, like cubic, or even trigonometry, which we haven't touched yet? So ask few questions. Forget about the question for like a minute or 30 seconds. Try to understand the nature, understand the nature of the cost or any kind of function that is in front of you before you go on and answer. So let's assume that this cost function is estimated by an economist or econometrician. So it's given to us, and they said that is what m raised to the power of 3. And this is a cubic function because the highest power here, this is 30 m raised to the power of 2 plus 500m plus 200. So this is a cost function. If you look at the materials I shared with you, you will see this example there. And first, before we even go to the questions, we have, I think, 2 or 3 questions. Before we even go there, let's try to understand the nature of this cost function. Obviously, one thing we can talk about, this is not quadratic. The highest power there is not 2, but what? 3. So we call it cubic function. We haven't looked at cubic equation, but even with that, we can still solve this. So we know it's a cubic function, and cost, this is we know that a m there is the quantity that is produced, and the quantity produced there is what? The trade mills. So the cost of producing trade mills, the total, remember this is total cost of producing trade mills, is this function. So after that, always when you are dealing with costs, always try to know the variable component there. And here, if you looked at it very well, the variable component there is what? M raised to the power of 3 minus 30m raised to the power of 2 plus 500m. Obviously, then we have the fixed cost component. The name is very self-explanatory, which is 200. So it's only when you add variable cost and fixed cost, then you will have total cost function. So in terms of visualization or geometry or graphical representation of this cost function, it's very straightforward. We will have what? M, which is the quantity of treadmills that is produced. And then on the vertical axis, we have total cost function. So obviously, since fixed cost is fixed, so we'll have 200 here. So we know that if treadmill, the number of treadmill produced is 0, so this function m, if you substitute m with 0 in the variable cost, at 0, then the variable cost will be 0. So this is more like a cubic function, you know, we will have something like this. You understand? So it goes like something like this. So, you know, the variable cost will be increasing. So this will be a, you know, this is not the exact function, but I'm just trying to give you the geometrical intuition, how this cost function will look like. So we'll have a variable cost here, and this is fixed cost. So you will realize that the variable cost is increasing as the quantity of treadmills that we produce increases. The question didn't ask us this, but you should be able to know this as a business, economics, or social science, other social science, says students. We should be able to visualize this. Once you see cost function, this should come to your mind. I'm having two components here, the variable component and the fixed component. So you have a fixed component, irrespective of whether you produce treadmills, you will incur this cost. This has to do with the machines that you will buy and orders before even production takes place. So now that we understand the nature of this cost function, now let's go on and answer some questions related to it. The first question A, it is asking us what is the cost of manufacturing ten treadmills. So this is the question. So in another word, with mathematical notation, what this question is asking us is this. So we know that this is the total cost function. So if they ask us what is the total cost of manufacturing 10 treadmills, obviously it's asking us to find this. So which is very simple. All what you need to do, wherever you see m, you substitute in the total cost function, you substitute it with the value 10. It's just to evaluate a function, which we did before. So to do that is very simple. We have 10, and we have our cost function, which is, we have stated it, that is what? M cubed minus 30 m square plus 500 m, then plus 200. So all what we need to do, wherever you see m here, you substitute it with 10. So this will be 10,000. So minus 30 in bracket 10, this to the power of 2. Then we have 500 plus 500, 10, then plus 200. So at the end of the day, we will have 3,000. The cost of producing 10 treadmills is 3,200. So this is our first question. So the second question is asking us what the average cost of producing. So question 2 is asking us what? What is the average cost? Average cost of producing 10 treadmills. So mathematically, this what is asking us is like, we have average cost, which is a function of treadmills. So equivalently, average cost of producing 10 mil is this. So this is what it is asking us to calculate. So all these words here just is this what is asking us to calculate. So to do that also, you just find your average cost there. You can find the average cost and then you substitute it. Remember our average cost, we know that the average cost is what? You have to take total cost divided by M. So obviously, if you want to save time, we have calculated it, this already. So average cost of producing 10 treadmill is just as the total cost of 10 treadmill divided by this. Obviously, we have known this. We calculated this already. If you remember, we have calculated the total cost of 10 treadmills. We have 3,200. So this will be 3,200. And the M is what? 10. So obviously, we will have this cancel, so we will have 320 as average cost. So average cost of producing 10 trade meals, it will be 320. We have that. Equivalently, so someone can calculate the average cost function, then after when you are done, then you substitute 10 there. It will give you the same answer. So we have question 2. Then let's look at question 3, which is very, very important. Most students confuse this statement. So let's pay attention. We have this, and it's saying there, what is the cost of producing 10 treadmills? So let's look at this question very closely. So the key word is here is this. If we go back, here is only 10. There is no TH there. So once you see this TH there, what it's trying to tell you is we are looking at what? That incremental cost. We are looking at the incremental cost. Some people will call it what? Additional cost. Or in economics, you will be hearing what? Marginal cost. So when we talked about the 10, it is asking you to calculate the marginal cost, the extra cost of producing the 10 treadmill. And if we want to know that, it will be what? The total cost of producing 10 treadmill minus the total cost of producing the 9 treadmills. So this will give you what? The cost of producing is what? Cost of producing 10th trade mill. So in another word, the cost of producing the 10th trade mill, we can just say that marginal cost. We can use this symbol. So marginal cost of this. So when you are asked to calculate the marginal cost of producing 10 trade mill, all what you need to do is what? C10 minus C9. So whenever you see this, it's just that they are asking you to calculate this, the marginal cost or the incremental cost or the additional cost. So we are going to go on and calculate this, find this expression in our next slide. So our marginal cost of producing 10th trade mill, we see the cost of producing 10 trade mill minus the cost of producing 9 trade mill. Obviously, we found this already. It's what, 3,200. So we know this also. If you find this, so this means you take the cost function and substitute wherever you see the M there, the trade mill. So if you do that, we will have something like 2,999. So the marginal cost of producing the 10th trade mill is 3,200 minus 2,999, which will give us what? 201. So this is the marginal cost of producing 10 trade mill. So this is the incremental cost. That is the cost that we incur in producing. For example, we have this quantity like this. So this is the trade mill M. So we are here 9. We will produce 9 trade mills. So we want produce, after that we produce 10. So this question, this marginal cost is the cost. We have this here. So this is the total cost of producing 9. So this is what? The total cost of producing the 10 trade mill. So from here to here, this is what, yes?
Mr. Tour, how did you get the 299? I didn't see that.
299, okay. I'm trying to save time. So it is 299. When you substitute, like this is the cost function. Where is it? Where is the cost function? So I guess I have to do that again. So we have our cost function here. So the 299, this is what I did. Equals to, I just substitute the 9 into the total cost function minus 30, then 9 raised to the power of 2 plus 500 in bracket 9 plus 200. So if you evaluate this, it should give you
Okay.
2,999. So yeah. So this one we know that is what? 2,999, and this one is what? 3,200. So the difference is the marginal cost. This cost we have here is the marginal cost of 10 trade mill.
Yeah.
So we haven't started like the differentiation or calculus itself, but there is a way of instead of subtracting this total cost of producing 10 trade mill minus the total cost of producing 9 trade mills, calculus will simplify this, which we will do. I hope we will have time, because I heard the semester is coming to an end. So if it's calculus, what it will do, this is just additional. So if you don't get it, it's okay, we'll get there. But if it's calculus, it's very, very simple. We have m raised to the power of 3 minus 30, 2 plus 500m plus 200. So first calculus, because we want to know what the marginal cost of producing 10. So what calculus will do, it will differentiate this function. How do we differentiate a function? first, this is the sign of differentiation, is equals to. So to differentiate this, the power will come down. Now we are looking at this. You write the m, so you subtract 1 from the power. Minus 30. Remember, this, we multiply this, so 2 will come down. We multiply by 30, so it will be m 2 minus 1. So this, the power here is 1, so it will be 500 times 1, which is 500. This is 1 minus 1. Then if you differentiate a constant, is 0. So at the end of the day, with this calculus, you'll have this. So this will be 3m2. This will be minus 60. 2 minus 1 is 1. If you want, you write it or you leave it. This is 500. So 1 minus 1, this will be 0. M raised to the power of 0 is 1. So you have this. So this is your marginal cost function. So all what you need to do to find the marginal cost of producing the tent, if you substitute 10 into this, it should give you the same answer as this. So we have 10 plus 500. So it should give you the same answer as what we got here. But this is calculus, like this one, 201. Like this space here is 201. So our marginal cost of producing tent, like the question, you understand, is 201. So calculus can do this faster, but we do it step by step. So all what you need to know for now, it's up to here. So with this, it's just for additional knowledge. If you want to take it, fine. If not, we can leave it until we read there. If you have a question, you can ask before we move on to composite function. We will look at that briefly, and then we will call it a day. Any question, comment that you want to share it with the class is highly welcomed. It's not easy, I know, this online lecturing. It's not like a traditional way of lecturing. So there are a lot of hitches and obstacles here and there. So if you have any problem, you can share it with the class. If I don't have solution, probably one of the students or your colleague might have. So if you have any concern, you can raise it. It's highly welcome. The floor is open. Okay. It seems like there is no question, no observation or comment. So let's briefly look at composite function. And
Mr. Ture, may I have observation?
okay.
Like you said, this online class is not as effective as it should be. Of course, there are hiccups somewhere.
Yeah.
Yeah, it is unlike when we are in class.
Exactly.
Perhaps you can easily understand certain things easier in the classroom than this.
Exactly.
I think the management should come up with a module, sort of, at least, because it's like this. I'm sure the grades will not be as better as compared to when you're in classroom.
Okay.
So I think the management should come up with a solution, sort of.
Okay.
That's just my thought.
No, it's okay. It's okay. You can go.
At least for it to be very effective, I think they should come up with incentives.